Hello everyone, welcome to this session. Our chapter is reading and interpreting topographical maps. So far, we've covered the elemental survey. In previous session, we saw the leveling survey. So today, let's move on to this chapter, reading and interpreting the topographical maps. So we'll start discussing basically the various features on the map. Now, from there, we have to first see the introduction to the topographical maps. What are topographical maps? The topographical maps, these are just types of the maps which they describe the physical, that is the natural features, and the man-made, that is artificial cultural features of a given area. So the topographical maps, they describe these two things, the physical features and the man-made features. So when we talk about the physical features, we include things like relief features, vegetation, drainage, and among others. And some of the other, when we talk about the cultural or artificial features, you're talking about those man-made features, such as roads, railways, cities, towns, dams, schools, and many other structures built by man. So yeah, basically seeing these two, we cover up about the topographical maps. Now, let's see the relief features. Relief features, these are just relief is just refers to the physical landscape as shown by the configuration of the surface of the earth that is brought about by a landform features. So relief are just the physical landscapes that can be illustrated on these maps. So they are just referring to the physical landscapes as shown by various configuration of the surface of the earth. That is simply brought by the landform features. So the methods on how you can show or yes you can illustrate the relief in the topographical maps, they include as follows. So there's the use of the spot heights, trigonometrical stations, contour lines, form lines, layer coloring or tinting, etc. So we'll see all of this in this session. So let's discuss each one of them, starting with the first one, spot height. Spot height, this is just a point on a map which with its exact height about or just above a known level, for example, from the sea level. So a spot height is used to illustrate or just to present or represent these relief features. So it's just a point on the map with its exact height just of above a known value or a known level, for example, from the sea level. The position and the height of the points have been determined by the surveyors. So these points and positions and the heights of the various points, they've just been determined by the surveyors, and that's how we can see them in the topographical map. The spot height is marked with a dot followed by numbers indicating the height of the land. For example, dot then 750. So just after being observed or being described by the surveyors. So the spot height that you see in the topographical map can be of example like this, dot 750. So it just shows a point of a given height of the non-relief feature that is found within that given area. The units of height, whether in meters or feet, are quoted in the key of the map as well as below the linear scale, so you can get them there. Spot heights are useful as a guide just to the general relief of the area, so are very useful just to the general relief of the area, so you can simply understand the general information about the given area by using these spot heights. The map user can easily determine the high points of the area, especially where the area represented on the map is an undulating plain or plateau. So that's how easily a map user can see or can determine. Now let's move on to the other way on how we can use to see or observe the relief features. Trigonometric stations or points. So what are these? Trigonometric station, this is just a point on a map with its exact height fixed, usually on a hilltop, mountain, peak, or other visible positions. So that's what a trigonometric station is. They are the highest points on any locality. The trigonometrical points are just commonly marked by a triangle followed by the numbers indicating the height. For example, triangle then 725. So this is an example of a trigonometric station, and you can simply see them in the topographical maps. The other one is hill shading. So this is the other way on how you can observe, or the other way you can use to see the relief features. Hill shading. Hill shading, what does it mean? Hill shading, this is the method of representing the relief on the map by shading the hills as if light is shining on them. So this is just a specific way of showing these hills. It's just this method of representing the relief on the map by shading the hills as just simply as if light is shining on them. So you can simply see them in a given topographical map. Hill shading depicts the shadows that would be cast by high ground if light were shining from the certain direction. So that's what they are. Here is how you can see the hill shading specifically on the topographical map. So this is the illustration of how you can see it in the topographical map, hill shading. Moving on, layer coloring or tilting. This is just a method of showing relief by color. So you can simply show the relief features by using color. A different color is used for each band of elevation, and you can simply understand them there. Each shade of color or band represents a definite elevation range. So that's the layer coloring or tilting. A key is presented or printed on the map margin just to indicate the elevation range represented by each color. So the key is very crucial when you are using this layer coloring, as it shows what each color means or what it represents. However, this method does not allow the map user to determine the exact elevation of a specific point. Only the range can be determined. So the layer coloring is very specifically only for the range determination of the various points. You cannot use, or the map user is not simply just easily allowed to determine the exact elevation of a given specific point. Moving on, the hatches. These are short broken lines used to show relief. They are there sometimes used with contour lines. They do not represent the exact elevation, but they are just mainly used to show large log outcrop areas. Hatches there are used extensively on small scale maps just to show mountain ranges, plateaus, and the mountain peaks. So these are the uses of these hatches. They're just used extensively on the small scale maps just to show mountain ranges, plateaus, and mountain peaks. Since the small scale maps, they have plenty of various relief features, and you might need them these just to show the details of these specific relief features, mountain ranges, plateaus, and mountain peaks. Hatches are also used to show the direction and the steepness of slopes, so that's the other use. And the lines are drawn to form the slope of the land and or in the direction in which the water would run on them. So here is just a simple illustration of how these hatches, how they can look on the topographical map. Moving on, let's see the contours. This is very common used in the topographical map. The contour lines, also called as isoheights, isoline or isopath, are just lines drawn on the map, joining all places with the same height above the sea level. The value of each contour line is written on it, and they are normally drawn in thick brown color. So that's the simple or just the normal representation of these contours on the topographical map. The contours, they simply do not cross one another for the simple reason that a single point cannot have two different heights. So this is the crucial thing to note about the contours. The contours, they never cross to one another, because the reason behind it that the every single point of the contour holds its given heights. So a single point cannot have two different heights. So that's the reason behind it. If contours appear on a map to be merging, it is an indication of very steep slope that is vertical or nearly vertical. So here just see the description of how the contours can look in the topographical map and how you can identify or how you can understand them. If the contours on the map can seen to be merging, it is an indication of very steep slope that is vertical or just nearly vertical. The contour of higher value obscures those below it. And the contour interval, this is just the difference in the height between the NA2 successive contours. So you can see this term contour interval. This is just the difference between the height between the two successive contours. It is also known as the vertical interval of the map. The contour interval is constant for all areas of a given map. So when a certain kind of a contour interval is given for the map, so it's constant for all of the given areas within the map. Contours are very useful as they help in the identifying various landforms, including type and trend of the slope of the land. So that's the reason why they are very useful. Uh, the shape formed by the collection of the contours enables us to just identify different types of landforms. The succession of the contour, yes, it enables us to see the changes in the relief. And here is a simple illustration of the contours, how they might look on your topographical map. So that's contours. Last but not least, let's see the form lines. The form lines, these are just lines of the map which join points of the approximately same height above the sea level. These are just used as fill-in lines to show out the nature of the slope or just given form of the land and the various landforms, hence the name the form lines. They are drawn by estimating the height of the land with the help of the spot haze and the trigonometrical stations as well as the contours. So the form lines, they are used in relation to these other ways of presenting these relief features, the spot haze, the trigonometrical stations, as well as the contours. They are usually drawn in the thin brown lines, and their values are just not normally shown on them. Contours and the form lines are just the main methods of showing relief on the topographical map. So these two are the main methods, and they are mostly used ones just to show the relief on the topographical map. For practical purpose, form lines are also regarding as contours on maps of scale maybe 1 to 50,000. They are just normal drawn in the brown color. Supporters and the trigonometrical sections as well are there also just to work on with the form lines. So that's all for this session. We've seen the various ways of presenting the relief features on the topographical map. We saw first what is the topographical map, and we discussed these methods clearly one by one, or just each one of them in detail. So that's all clear, and thank you.